Welcome. Thanks for joining. It's a good idea that you're here. Grab a notebook, get a pencil or a pen. Whatever you'd like to write with is fine. This is math from the void. Math coming at you out of nowhere. Today we have a problem from the 1999 AP Calculus exam. This problem came up on the AB exam and the BC exam. So if you're in AB, totally approachable. As usual, give your chance about 12 to 15 minutes for this. I believe this may be a calculator problem, but I'm going to do it without a calculator. I don't think it's a calculator problem, but it might be. Part C is a little bit tougher if you don't use a calculator. So when you're ready, you can come back, join us, because we're about to get started. Here we have a chart, and this chart gives us the rate at which water is flowing out of a pipe. So it tells us basically how fast water is flowing out. And it's a differentiable function r. The table above shows the rate measured every 3 hours, so you'll notice that sort of like the x values, or in this case the t values, are increasing by 3 at a time. First, they want us to use a midpoint Riemann sum with 4 subdivisions of equal length to approximate the integral, and then we have to describe what it represents. So if we're going from 0 to 24, and we want 4 subintervals, our subintervals are going to go and divide this in 4, obviously. But they want us to use midpoint approximations. So that means we're going to be using the midpoint in order to determine the height of these rectangle approximations. So really we're going to be approximating at 3 and 9 and 15 and 21. So that's really what we're going to be doing. But the width of these rectangles is 6. The height, however, like I said, is determined by these midpoints, not at 6, 12, 18, and 24. So let's see what we have. We have that the integral from 0 to 24 of r is approximately 6 times all of these heights. So we have 10.4 plus 11.2 plus 11.3 plus 10.2. I believe that's all of them. So let's add that all up. We're going to get, let's see, 42, 47, 43.1 times 6. This is 258.6. Now, this is adding up all of the gallons per hour. So if we add them all up, we're getting gallons. So that's how many gallons have leaked. Someone needs to fix the leak. That's for sure. Okay, let's take a look at part B. This is a pretty easy question. Is there some time such that r prime equals 0? Well, it's basically asking if the derivative is ever equal to 0 at some point. And so in order to answer that, we pretty much just have to find an interval where the average on that interval is 0. Because MVT applies, so if f of b, I guess I can just say r for rate. If r of b minus r of a over b minus a equals 0 at some point, if the average slope is 0 at some point, then we know the exact slope would hit 0 at some point. So are there any spots where they have the exact same rate? Yeah, actually at the beginning and the end. Look at that. So we can say, since r of 24, so 24 hours later, minus r of 0, it's just equals 0. That means that r prime equals 0 at some point. Some point on the interval from 0 to 24. Let's see, I mean, that justifies the answer because the MVT applies and we used it. Yeah, there's no units required there. You just have to say that since the average slope was 0, then at some point the derivative was 0. Might have been many points that the derivative was 0. Could be many different points. But we know for sure that at least one point. Okay, part C. The rate of flow of water can be approximated. Okay, so they're giving us an equation. They're basically saying screw the table. Just use the equation. The equation approximates the water flow. Use Q of T to approximate the average rate of water flow. So the average value. You know how to find average value? We take an integral and divide it by the interval. So some people will write it like this, f of x dx. In this case, we're dealing with time instead of x, and we're dealing with q instead of f, but you get the idea. Okay, so let's find that integral. From 0 to 24, that means we're going 1 over 24 minus 0. Integral from 0 to 24. And is there a constant out there? There's like a 1 over 79. What the heck is up with that? Okay. 768 plus 23t minus t squared. Wow. 768 plus 23t minus t squared. Okay, what am I getting myself into here? Let's take the 79 out. So we're going to pull that all out there. Let's see, 24 times 79, right. 96, 960. 1920 minus 24 is 1896. And then this is going to be integral, or I guess I can just anti-differentiate it now. This is going to be 768t plus 23t squared over 2 minus t cubed over 3. And that's going to be from 0 to 24. So of course, if you plug in 0, you're just going to get 0. The tough part here is plugging in 24. So let's see how that goes. 24 squared, I know, is 576. Let's try to multiply that by another 24 here. Here we go. 4, 2, 30, 42, 4, 24, 38, 3, that's 13. That's what I'm getting. 13, 8, 24, and I need to divide that by 3. Serious? Okay. We're gonna divide this by 3, so we're gonna end up with 4608. All right, I guess this is not going so badly. 23 times 576. Well, 24 times 576 is 13,824. So 23. It's 13,824. So 23 times 576. We can just subtract 576. Which, if I add 24 to both of those, just turns into 13,848 and 600. So this is 13,248. And then I'm going to divide that by 2. So this is going to be 6,624. And then here's the big one, 768 times 24. Yowza. You know, a good way of doing this is just saying 192.00 minus 768. So let's raise everything by 32. So this is going to be 18432. We're almost there, everybody. We are almost there. Can you feel it? And we're going to divide by 1896 at the end. So let's get these together. That's going to make 25056 minus 4608. So we're going to have 448. And you're multiplying, or I guess you're dividing by this. Oof, guys, we're almost there. Divide by 1896. And I'm pretty sure that'll give us our answer. Yeah, let's do it. So what is this going to give us? This is going to give us a 1 right there, 1896. Subtract that. If we add 4, that's like 48. So 148. Yeah, sounds about right. And then an 8, so we get 0. Let's add a 0 there. Usually they want 3 decimal places, so we can do this. It's 3 decimal places. 1896, it's almost 19, right? It's almost 19. So I'm going to go 7 times. And let's see, that's going to be 2, 4, 7, 6, 2, 6. There we go. Feel the stress lifting. We're getting that much closer. That one's going to take another one, so this is going to be an 8. So this is going to be 48. So 4, 6, 7, 1, 7, 15. We are almost there, everybody. This is 12. This is 9. Here goes another 0. That's going to be approximately 4. Does it make 5? Yeah, it does not make 5. So here we go. 4, 24, 2, that's 38, 3, that's 35, 3, that's a 7. And I think that's good enough. So we're going to say 10.784. That is our approximate value. So we get a different approximate value for the integral. Now this is not just the integral. This is the average value. So we'll say 10.784 gallons per hour. Because the values of R are in terms of gallons per hour. These are rates. So we're saying like the average amount of leakage per hour, basically, was 10.784. Which when you look at the chart, it does kind of make sense. That seems to be about like the average. Things were sitting around 10.7. And yeah, indicating units of measure, guys, this is going to give you 1 point. If you don't have indicating units of measure on every single part, you're going to lose a point out of 9 for like no reason. So make sure you use units. Like I said, this was probably a calculator problem now that I look at all the calculations that I did. I don't think they had this going that strong in 1999. This is what my AP exam looked like when I took it, not in 1999, but when I took my AP exam. It just looked like a crazy person's scratch work, honestly. But it looked even crazier than this, because here I tried to make it at least somewhat instructional and take you through the process of what it would be like and what you need to consider. So stay sharp, make sure you're studying, get good sleep, all that jazz, all those good healthy study tips for your brain. And that's enough blab out of me. So I'll catch you guys next time in the void.